Something else that's going on, you see that white layer? That's the result of a massive eruption from Mount St. Helens that was occurring during this flood event. And it makes sense, because if you start thinking about it, how much does 7 million cubic miles of ice weigh? And what happens when you start transferring that mass from the continent back to the ocean basins? What does it do to the subsurface areas, to the subterranean areas? What kind of stresses does it induce? Well, there's Mars again, and there's eastern Washington. And all you have to do is add a little water to that Martian landscape and grow some scrub, and it would look just like this. So what we've got here is this transplanetary understanding that we can look at Mars and learn things about Earth by looking at Mars. Here's the Basin and Range province of the West. While all this flooding was going on up here in the Pacific Northwest, that's Great Salt Lake right there. There's Death Valley down there. This is mostly Nevada right here. Well, during that flooding, this is what happened. It turned into a giant inland sea. And it was so huge that it breached several mountain ranges to the north side and flowed down the Snake River. And here's a beautiful example of scale and variance. Here's the modern Snake River, which is actually a pretty good-sized river. And you'll see it's flowing in a little channel down here. Well, you see the much bigger channel that was created during the end of the Ice Age floods. Now, here's the significance of this. Here you can very clearly see the two scales of phenomena, right? The small modern river and the ancient catastrophic flood river. Well, you could take any river valley in North America, and if you stripped away its forests and its vegetation, it would look like this. Every river valley in North America is an underfit stream, which is what geologists refer to this, meaning that it's flowing in a channel that's way outsized for the amount of water that's flowing in a modern river. But if you were to add forests and lush vegetation around here, you basically could duplicate every river in North America. In fact, I'll even go so far as to say virtually every river on Earth. Because what I'm showing you here, I'm showing you some of the more spectacular features here, but they would apply to almost anywhere. Oops, sorry. The Mojave Desert, gigantic riverbed. And there is this, it's from space. Can you see what do you see there? Look at the floor of the desert. The floor of the desert preserves the evidence of these past global changes. There it is. This is in southern Arizona, in the Sonoran Desert, at the on the flank of Saddle Mountain. Looking at, you can't see it from the ground because it's too subtle. But when you're in space or above, let's take a look. Here's Saddle Mountain, and all around it are these giant fans. And when we zoom in and look at those fans, what do we see? Ripples everywhere. Ripples. The whole floor of the desert is mantled with these ripples. Well, the desert itself is the byproduct of massive floods. We can hike all over the West in the streams, and what do we see? These giant flood-rolled boulders that aren't even begun to being moved by the modern stream flows. We see extinct cataracts all over. This is in Utah. And stripped landscapes. We see sandstone arches. Now, this is really interesting because modern geologists don't really have an explanation for how an arch like this might exist. But I want you to look. Right up there is a baby arch that never got finished. How do you create an arch like this? The modern slow erosion is slowly destroying that arch. How do you create an arch like that? Or like this one up in Kentucky, or numerous other ones? You do it with colks, which are whirlpool-like eddying currents created by extremely high velocity turbulent floodwaters that drilled deep potholes. And this is a graphic showing what it would look like underneath. They are literally underwater tornadoes. and they pick up the debris in the floodwaters, and they become like gigantic hydraulic drills. But the thing is that these colks can actually come up and turn horizontal. That's how you explain a sandstone arch or a giant pothole. And there are potholes, if you know where to look, there are potholes 20 feet wide and 100 feet deep that were created by colks. And they're found, I can take anybody here up to North Georgia, Tennessee, North Carolina. We can go hiking up stream valleys, and I can show you hundreds of potholes, giant potholes, that were formed by massive floods. Boulder fields like this that were just strewn and left in the wake of these events. Here's the kinds of things that you see when you hike the mountains of the southern Appalachians. Giant deposits of boulders like this. Potholes. You see that pothole? Now you know that pothole, how did it get there? It didn't get there by the modern flow. It got there because there was a turbulent colk, probably water moving through here 40 to 50 miles an hour and anywhere from 1 to 300 feet deep. And you can find this on virtually every stream channel in the southern United States, in the southern Appalachians. Look at the size of those rocks that have been transported and dumped. See, we're coming here to the eastern United States now, so I'm trying to show you that the phenomenon is not limited to any one state. Again, when you take a look at the subsurface architecture, what you discover is the evidence is there preserved as well. And now when you look at here's a riverbank up in Indiana, and take a look at these circular rounded pedestal-like. Well, now you can begin to understand how they're formed. Picture that vortex of whirling water cutting into the side of the riverbank right there, and you'll get the picture.
Randall, we have to wrap up.
Well, I guess we got to wrap it up, so I'm not going to be able to tell you what caused this flood, but I guess we'll save that for the next one.
Chapter 2. But we can do about 5 to 10 minutes for Q&A.
Of Q&A?
Yes, sir. So,
Okay, I can't tell you about Okotoks, the big rock. This will be the last thing I tell you about. This is truly remarkable. This sits out on the plains of western Canada. It's an 18,000-ton metaquartzite boulder transported by an iceberg about 200 miles from its source up in Mount Robeson and Mount Edith Cavell in the Canadian Rockies. It's part of a chain of rocks that's 500 miles long. It was transported intact and didn't break until it was set down in the soft sediment. What's really bizarre about this is that this metaquartzite rock, like I said, it's in Alberta, out on the prairies, on the eastern side of the Canadian Rockies, on the eastern side of the Continental Divide. The mountain that it came from is on the other side of the Continental Divide. We're talking here about some kind of a force or power that's able to excavate an 18,000-ton boulder, lift it over the Continental Divide, and drop it on the prairie of Western Canada. How do you do that, John? If you had a contract to move an 18,000-ton rock like that, how would you do it?